So guys, welcome to Ask IITians. My name is Gaurav Yadav. I hope you all are doing well, right? Today we want to discuss about a chapter, a very important chapter for human standard, that is circle, right? Guys, let me tell you that this chapter is not only important for human, but also important for your 10th also, for your 11th also, for your 12th also, even for your engineering also, like whatever you are going to do in your future, right? So this chapter is very much important chapter. So without wasting time, let me share my screen, right? Yeah, guys, perfect. So class 9 circles, its CBSE weightage is your 3 to 6 marks, right? 3 to 6 marks questions will be asked from circle chapter. Okay. Okay. So in 10, the chapter becomes circle, then A related to circle, right? And in your for your 11 and for your 12 you study separate, right? In your phonics circles you study circles, educational circle, right? So today topic we cover will be okay. Okay. So today we'll cover topic tangent and its properties, right? And problem involving multiple circles internally and externally, right? Guys, let me tell you first thing what is tangent. I think I have already told you that a line and a circle can have only three conditions, right? If a circle is there, right? Only three conditions and a line and circle intersection can be there, right? Let me write here three conditions of line and circle intersection, right? Three conditions for line and circle intersection, right? Like line can, like a line can be there which do not pass through a circle. A line can be there which just touches the circle. A line can be there with just intersect the circle at 2 points, right? So in case of first, in case of this can be your case two, this can be your case three, right? So in first, if line does not intersect your circle, then these both are independent bodies. Like there will be no relation, no relation. Why? Because both are different bodies. A circle is there, a line is there, no relation. If the circle touches this, if your line touches the circle at a single point, right, then it is known as tangent. Tangent. If your if a line intersect the circle at two distinct points, then it is known as second, right? Then it is known as second. I think the point is clear. Okay. So tangent is basically a line which just touches or intersect the circle at only a single point, right? Tangent and its property will study property later, right? Okay. Okay. If a circle is there, right? If a circle is there, and okay, let me just erase that, huh? Okay, so a circle and a point can have also three relation, right? Now we are discussing between three conditions, right? Three conditions for point and circle, right? There can be only three conditions. Like if your point is within the circle, right? Like this can be your first condition, and this can be your second condition, and this can be your third condition, right? If your point is within the circle, then in this case, no tangent is there, right? No tangent. If your point lies on the circumference, then there will be only a single tangent. Then in case only one tangent, okay? If your point lies outside the circle, that point P, right? Like this point also be P, then this point also be P. If your point is outside the circle, then there will be only two tangents, right? Exterior point, and there will be two tangent touching the circle, and both tangent will be equal. Why? Let me show here only. Why? Because suppose this point is O, right? Okay, one more point is there. Like if a tangent is there, then your center, a line from your center will be perpendicular, right? Perpendicular, right? So these points, let's suppose you A and B, your angle A and angle B will be your 90 degree, right? If these are 90 degree, you can take your two triangles. You can take two triangles, triangle OPB and triangle OAB, right? So here OA is equal to OA is equal to OB. Why? Because of radius, right? Your angle A is equal to angle of B, and both are equal to 90 degree, right? And your OP is equal to OB. So it means by your RHS or SAS, right? Triangle of OPB will be congruent to triangle OAP, right? It means your PB will be equal to AP. Why? Because of your biassicity, right? Corresponding parts of congruent triangle. So yeah, hence we can prove that if an external point is there outside the circle, then only two tangents will be there, right? And both tangents will be equal, and also the tangent will subtend, the exterior point will subtend at equal angles at the center, right? These angles are equal. Why? Because of the same symmetry. I think the point is much clear to you. I have just overview what you will study and why, what you should know, right? These are some basic property you should know, or you have already covered, right? We'll now study more concepts and more question regarding, right? Okay. So yeah, tangent and its property. Just look at the diagram. What diagram is saying, right? If at any point is there, right? Your green arrow is showing that this will be your tangent at a single point, right? So a tangent to a circle is a line which intersects the circle at only one point. At only one point, guys. This point is very much clear. At only one point. The common point between the tangent and the circle is point of contact. Okay, like this point, your P point, the common point between a circle and a line is known as your point of contact. Point of contact, right? I think the concept is clear. And also from your center to the point of contact, this is your perpendicular. Your OP will be perpendicular to AB, right? A line from your center to the point of contact, or you can say to the tangent, is perpendicular, right? And your point of contact is also known as point of tangency, right? This is also known as point of tangency. I think the point is very much clear to you guys, right? Okay, we'll now study about properties of your tangent, right? Very much important for you. Okay, the first one says the tangent never crosses the circle, it just touches the circle, right? It just touches the circle at one point. One point. What if it crosses the circle? Then it is known as second rise. I think I have already told you in our previous slide, right? If it crosses the circle at 2 points, then it is known as your second, right? At the point of tangency, it is perpendicular to the radius, like we have already covered that your OP will be perpendicular to your AB, right? In this case, like suppose the point of tangency is basically a point of contact, right? If you join this O point and P point, right? So this will be a perpendicular, right? At point of tangency, it is perpendicular to the radius. Okay. The next third point is a chord and a tangent form an angle, and this angle is same as that of tangent described on the opposite side of a chord. Right? I will make it clear what the font is saying. So the last one is from the same external point. The tangent segment to a circle are equal. This point is like if a circle is there and the external point is there, right? External point is there. Then these, sorry. then these tangents, okay, then basically these two tangents are equal. Okay, if a point is there outside the circle, then these two tangents are equal. Okay, let me show what the point is saying. If a circle is there, like we have already covered this, right? If these are two tangents, right? If these are two tangents, suppose this P and this your center is O, then your A and B. Your A and B are your point of tangency or can say point of contact, right? So in this case, your AP is equal to PB. Like we have already proved it. We have already proved that here both the tangents are equal to each other. Okay? So now let's say what the third one is saying. A chord and a tangent form an angle. Okay, suppose that if a circle is there, right? And this is your tangent, right? Line is not okay. So a chord and a tangent form an angle. And this angle is same as that of the tangent described on the opposite side of the chord. Like a chord is there, right? If a chord is there and a chord makes some angle about the theta, then a chord will make the same angle at opposite side of the chord, right? If your this angle is your theta, then your opposite side, like this point is suppose P, and B, right? And suppose this point is Q. The third one is saying like if your APB, angle of APB is equal to theta, then therefore your point of like your angle B will also be theta, right? Just keep in mind this it is basically a square of right angle property, right? Angle property of a chord and a tangent, right? Opposite angle is always equal to your the angle made by a chord and a tangent, right? So this angle will also be theta. We'll move further. We'll do a question regarding it, right? Okay, so guys, this question is very much important to clear all your concepts regarding your tangent, regarding your angle at the circumference, right? So if you have done this question, it means your concept is very much clear. I'm just leaving this question for you. Just try to solve it, right? After that, I will solve. Just find the value. Find the value. Like let us first uh, read the question, right? In the following diagram, P and PV are tangents. It is saying that PA and PB are tangents. Like you know by property that your all tangents, your both tangents are equal, right? Find the value of OAP, right? It is asking you OA and P. What is OAP? Just tell me, guys, think about it. What will be the angle of your OA and P? Guess the angle, like what will be the angle of your OA and P? Okay, so like let me solve it, right? Your O is your center, your A is your point of contact. Your A is your point of contact. And you already know that your point of contact, your A will make 90 degrees, right? You know that at the point of tangency, the center, the radius makes an angle of 90 degrees. So both angles are equal. So the question is asking OAP. So OAP will definitely what? It will be 90. I think no one will have a problem in this, right? We have already proved like you at the point of tangency, the radius makes an angle of 90 degrees, right, guys? So the next is angle AOB. AOB. AOB, guys. This okay. So the question is asking AOB. It means it is asking about this angle. What will be the angle of AOB? Guys, this question is very much important, right? Because it will make your concept very clear regarding your tangent, regarding your circle, regarding your angle and the circumference, right? All angles will be clear by this single question, right? That's why we have put. So, angle of AOB, you have to find angle AOB, right? Okay. So, guys, if you think about, like, in in quadrilateral, in quadrilateral PBOA, if we take a quadrilateral PBOA, in quadrilateral PBOA, okay. Angle all angle sums will be equal to your what? All angle sum will be equal to your 360. In any quadrature, all angle sum is equal to 360. So your angle P plus angle B plus your angle O. It is basically asking about angle O, right? Or you can also write your angle AOB, right? Plus angle A is equal to your 360. I think the point is very much clear, right? So angle P is what? Angle P is your 48 degree plus what is angle B? Angle B is your 90 degree. Why? Because your radius makes an angle of 90 degree at the point of angle B. Angle O you do not know and you have to already find it, right? And angle of A. Angle A is also 90 degree, right? Is equal to 360. And 90 will become 180 and 360 minus 180 is also 180. So just angle O will be equal to 180 degree minus 48 degree, right? So 10 minus 8 will be 2. Then 7 will become 7 minus 4 will be 3. So 132. Your angle will be your 132 degree. What? Angle AOB. Angle O is just basically angle of AOB. So 132 degree. Okay. So guys, the next is angle OBA. Okay. So the next is angle OBA. Try to find out what will be the angle of OBA. Right? This is your OBA. Also, the question can also be asked what will be the angle of OAB. Right? Think about it. Think about it. Try to solve. And let me tell you one more thing. Right? Your OBA and if the question will ask about your OAB, both will be equal. Right? I will give you the reason. Right? Just focus on the first. Focus on the diagram. Right? Focus on a single triangle. Which triangle? Your O, your B. I'm making it large here. O, B, and A. Right? You already know the value of O. 132. 132 degrees. Okay. So how will you find angle P and angle A here, right? The main point is you already know that your OB and your OA are both radius. Both radius. It means they will be equal. If they are equal, it means your OBA is an isosceles triangle. And you know the property of isosceles triangle. That if in any isosceles triangle, the opposite angles are equal, right? These angles are equal. Let's suppose these angles are x, both x. You know, in triangle OB, we are talking about in triangle OAB. Your all angle sums will be equal to 180, right? So your 132 angle, your angle O, the angle B is your x, the angle A is also your x, will be all equal to 180, right? So 2x, your 2x will be become 180 minus 32. 180 minus 32 will become 48, right? So x is basically will become 24 and your x is the same angle at B, which is basically your OBA also equal to just make a point here also like if question I have asked OBA and OAB both are equal. So we can also write angle of OAB. The last point and the very much important point for your this question, right? Which will make this concept more clear, right? Question has asked about angle ASB. The ASB, what will be the angle of ASB? Just tell me, guys, what will be the angle of ASB? Try to find out. We have already studied about this property, right? Let me tell you one thing that in a circle, if you know, in a circle, if any arc or any chord is there, right? Any arc, let's suppose arc, right? If it makes an angle of 2x at the center, then at any circumference the angle will be of x. Right or not? I'm just writing angle at center. Angle at center is equal to twice twice angle at circumference. Just focus on your AB. Your AB is an arc which makes an angle O at the center. So your angle O will be equal to twice of what? Angle S. I think the point is clear. So angle O is nothing we have already found 132. So 132 is equal to twice of angle S. So your angle S will be equal to, so this is guys, angle X S will be A, which is basically ASB. Because this is angle. I think the point is clear and the question is a very good question to make your concepts clear, right? Let me summarize the question in a single flow, right? How will you find it? So the diagram, I think the diagram was clear. So yeah, diagram was clear. So only we were given only angle P. You the question has asked to find out the your angle OPB. Your angle OPB and your angle OAP will both be equal to 90 degree. Why we have already given the reason? Because your radius makes an angle of 90 degree at the point of tangents, right? So next was your AOB. AOB we have told definitely by making a separate diagram. The OAB, as both are radius, and right. Sorry. The first they asked like about angle O, about angle O. You know, in a quadrilateral, angle P plus A plus O will all be equal to this. So we have already found angle O. Angle O is just 132 degrees. Okay, so the next question has asked about this angle OAB, and O can also be asked about ABO. So both are these. This is only a associated triangle, right? You can easily find out that your x at 132, both sides are angles are equal, so you can find out that your x. So basically, this angle OBA and OAB both are equal to 24. Now the main chunk, the question is asked about your angle S. You should know the property, right? That your angle at the center is twice the angle at the circumference. So I think the point is clear. Your angle S will be equal to 60 degrees, right? So yeah, this is how it has found out, and just go through the solution. We have already done the same way in a only better way, right? So this is your basically the same solution, right? Let's go through it. Okay. So problems involving, okay. So problems involving multiple circles and touching internally and externally both. Yeah. So problems involving multiple circles touching internally and externally, right? Multiple problems, right? So first question is two circles that internally the sum of their area is given 116. It is basically 5 centimeters. The distance between their centers, one their area. Before discussing the question, let me tell you one thing, right? Only three conditions can be there between two circles and their intersection, right? So the same way we have done a point and a circle intersection and a line and a circle intersection, right? So if first condition can be there, like your circles do not intersect. Your circles do not intersect. Second condition can be your circles just touches. They do not intersect, just touches at a single point, right? And third condition can be there like your circles intersect. And the fourth main one, your circle lie within the other, right? And also one condition can be there, your circle touches touches internally. Your touches internally, right? So this is basically your, okay. Let me tell you your first one. This can be your second condition. Then this will be your third condition. Question can be asked in either form, right? Multiple circles internally and externally, right? We have for all third. Then your fourth one, it does not touches. Then a fifth one, right? Okay. In first condition, when both circles do not intersect, like guys, how many common tangents can be there? How many common tangents can be there? Let me show you, right? Only four tangents can be there. Common tangents. Four common tangents. Why? Like suppose this can be your tangent, right? Tangent, common tangent we are asking about, right? And also diagonal tangent, right? This line is going like this. So four tangents can be there. I think the point is clear. If circles do not intersect, right? What if circle intersect or touches this one point externally, right? So three tangents will be there, right? Three common tangents. If a line goes like this, secondly, if a line goes like this, and yeah, if line goes from the same point of tangency of both the circle. What if the circle touches, right, or intersects, right? So there can be only two tangents, right? How a tangent to a circle is aligned with just touching the circle. What if a circle lies inside the other, then no tangent and no tangents will be formed, right? What if a circle touches from inside internally, then only a single tangent, one tangent will be there in this case, right? I think the point is very much clear to you all. Only your five conditions can be there between circles. We have already covered the relationship between and the intersection of your circle and a point, your circle and a line, and now we are discussing intersection of the circle. Multiple times of intersection can be there, right? Okay. So now, yeah, come to the question, right? Come to the question. Two circles touching internally. What will be the like this question is in which form? Yeah, this question is your fifth form. This is what we are talking about. Internally, they are touching each other, right? Some of their areas is given. Suppose this radius will be one radius will be your R1, second radius will be your R2, right? The same diagram, fifth question. Like suppose the smaller circle have radius R1, bigger circle has your radius R2, right? A point is clear. Okay, and the distance between their center is 6, right? This is just basically telling like if your this is your R2 and this is your R1, your center, the distance between center is your 6 on the radii of the circle, right? So basically the first point is that pi of R1 square plus some of the areas is 116, pi of R2 square is equal to 1165. So this is your first condition, right? What is second? The distance between their centers is 6. The distance between their center is 6. It means basically your R2 minus R1 is equal to 6. Why? Just look at the diagram. The distance between them. If okay, let me show you with a nice diagram, right? First case, second case. If these are your center, okay. Guys, just tell me what will be the length of this. This is your R whole radius, right? Okay, what will be the length of this one to this? This is your R1. So the remaining is your distance between your center D, which is basically your R2 minus R1, right? Just put in the formula and try to substitute it. You will easily get the area of a circle, right? Let me show you how the solution is, right? So I think the first point is very much clear to you, which is basically the sum of the areas in conversely. Just put the value of R1 R2, right? And the distance between center is R1 plus R2 equal to 6, right? Both conditions are there. Just substitute the value of R1 from your equation second and put in the value of your first, right? So 6 plus R2 whole square will be equal to R2 square 116. So you will open the formula and try to solve this, right? So your R2 will be your either minus 10 by solving the quadratic equation or will be equal to your 4. So it can't take your negative value, it means your hence your R1 your R2 will be your basically 4. If your R2 is 4, then your R1 will be your 10, right? Because the difference is 6. I think the point is clear, right? This is your basically R2. Okay, say R1, R2 both, right? Let's say R2, right? And suppose the center is there, then this whole will be your R1. So basically, the distance between the center will be the difference of their radii, which is basically R1 plus R2. or R2 minus R1, you can put either of them and try to solve accordingly. In case of R2 minus R1, your R2 will be 10, your R1 will be 4. If R1 minus R2, then your R1 will be smaller, R2 will be big, R1 will be bigger, your R2 will be smaller, right? I think the question is clear to you or very simple, right? You have already considered the all possibilities of intersection of the circle, right? Let us now, guys, now move forward for this question, right? A very good question, a very good question asked. Yeah. So the question is telling, the question is telling two circles with radius A and B. Two circles are here, right? A with radius A, with radius B. Touches each other externally. These are touching each other externally, right? Let C be the radius of the circle which touches the circle as well as, guys, let me tell you that this question is asked in your Olympiads also, right? This question, the same question is asked in your Olympiad also, right? So look at the question carefully that the circles A and B touches each other externally. It is touching each other externally, right? And C with the radius of a circle which touches the circle as well as the common tangent. Okay. So this is the basically circle or smaller circle touching both the circle externally. It is the condition of your three circles touching each other externally, right? And also touching the common tangent which is BD. Okay. So you need to prove that your 1 upon under root of C. Your C is basically radius of your smaller circle. It will be equal to your 1 upon under root of A plus 1 upon under root of B. Guys, just look at the diagram, then I will show you how to prove it, right? Just look at the diagram. How are you gonna prove it? Try to solve it, guys. If you understand this diagram, it means your concept is good, right? Okay. So basically, your BD is your common tangent, right? Let's say your BD is of length like T. BD is of length your 4 T. BD is your common tangent, right? And suppose your BC, B to C point is your X, right? Let me tell you that both all angles are 180. Oh, sorry, 90. The B angle is 90, your D angle is 90. Okay. And suppose your BC is your X, so the remaining CD will be your D minus X, right? Your AB is your A. AB is basically your A. Guys, what will be the length of EF? You know that E to D, ED is basically your B radius, and your FD is aligned parallel to your AB, which is it will be equal to your A, right? So what will be the length of EF? EF will be your B minus A. I think the point is clear. Your EF. So just look at the triangle. I'm just writing the equation. You will solve it and you will get definitely get the desired result. In triangle AEF, right? In triangle AEF, right? So this angle is basically a 90 degree because the lines are parallel. Angle D is 90, so angle F is 90, right? So opposite to 90 degree is hypotenuse. It means your AE square, is equal to your EF square plus your AF square. What is AE square? AE square is your A plus B whole square. What is EF square? EF is basically B minus A. Will be your B minus A ka whole square, right? What is AF square? AF square is basically your D square. Why D square? Because your BD is parallel to AF, so if BD is D, right? So you will get the value of your D in terms of A and B, which is basically your 2 under root of AB. Open the formula, right, and make it to the single side, you will definitely get the value of D. D is basically your 2 under root of AB. I think the point is clear, right? So D is equal to 2 of root AB, right? This is your first right? Now look at the diagram and what can you say about your in triangle AHC? Like we are looking for your triangle your AHG, right? So yeah, this is also your 90 degree. Guys, what is AG? So in this triangle, AG square is equal to your AX square plus XG square. XG square. What is AG square? AG is basically the distance of your centers, right? So it is basically your A plus C whole square. A plus C whole square, right? If AG is A plus C, right? And what is AH? AH. What is AH? AH is basically your A minus C whole square. And what is XG square? XG is basically your X square. So you will also get your value of X as 2 under root of A. Let me tell you that your AH is basically your whole AB minus your HB, and HB is your C because of radius, right? So you have get the value of D, you have got the value of X. Now look at the diagram and look at your triangle GEI. GEI. In triangle GEI, your GE square is equal to EI square plus IG square, right? So both from your three, one condition will come out from this, right? From both three conditions, you can easily calculate that area. Let me show you how the solution is going, right? So it is basically your first condition, like we have already proved, right? First condition. The second condition is this. In triangle GEI, your the same Pythagoras we have written, right? P minus x whole square is equal to P plus C whole square minus B minus C whole square. So basically, your D minus. Try to solve it in your own copy, then you will clearly understand what is going on, right? 2BC, right? This is your third condition. So first, second, and third we have already got, right? So, but what is D from your first condition? D is your 2 under root of AB. Okay. What is X? X is basically 2 under root of AC is equal to 2 under root of BC. So 2, 2 and 2 from both these sides will cancel out. So you will get right. You will get under root of AB is equal to under root of AC plus under root of BC. Right. What if I divide both these sides by under root of ABC? Under root of ABC. Under root of ABC. Under root of ABC. Right. So under root of AB and root of AB will cancel out. You will it will become under root of C is equal to similarly under root of B under root of A. Guys, this question is very much important, right? Keep in mind the desired result. It can be asked in your exams, right? This question may be repeated, right? And I think the question has repeated several times also, right? So the question is basically three circles are there who are touching in a smaller circle is there, right? And all have the same tangent, right? If this is your C, this is your A, this is your radius B, then your smaller under root of reciprocal of your smaller circle is equal to 1 upon under root of A plus 1 upon under root of B. We have already proved that, right? Try to solve in your own by your own in your own copy, then you will easily get. Only three conditions are there. We have already taken only three circles, right? With the help of Pythagoras theorem, we have proved it, right? Okay, so next question is two circles touching externally, right? The sum of their areas is 135, 135, right? So let R1, R2, R1, R2 is given, right? So first question, first equation is pi of R1 square plus pi of R2 square is equal to 135. I'm not solving whole question. I'm just making equations. Try to calculate then further. You will easily get the radius of the curve. So the distance between them, R1 plus R2 is given. We have already done the same thing, right? So we are discussing the multiple types of intersection of your tangents, right? Whether externally, whether internally, right? Question based on it. So pi r1 square plus pi r2 square. So your first condition, first equation can further be improved if all pi will cancel out to r1 square plus r2 square will be equal to 1, right? Put the value of r1 or r2 from the second into your this equation, third equation, right? And try to find out the value of R1. If you know the value of R1, then R2 will be a 40 months R1, right? So this is what basically question is all about, right? With the help of both equations, you can easily go through it, right? Just go through it. It's very simple. You have just put it the value of your R2, right? And only this will be a quadratic equation. To solve it, your R1 will be your 11 or 3. R1 will be 11 or 3. If R1 is 11, then R2 will be your if 11, and in case of 3, if 3 in case of 11. So your both radius can be either 3 or 11 or 11 or 3, right? It does not depend, right? Next, okay guys, so these are basically practice questions for you guys, right? Okay, second question is important. Also, first question is important, right? So these are basically your homework, right? Try to solve these questions. Let me try to solve your first question. Second question to you do by yourself, right? So angle, you have to measure the angle O. You have to measure this angle O. What will be the angle O? You know that this angle is 90 degree. Why 90 degree? Because your radius makes an angle of 90 degree at point of contact or point of tangency, right? So in triangle, O is that O A. In triangle O is angle O plus angle A, right, plus angle C is equal to 180 degree. Angle O is basically you have to find out the angle A is 38 and angle C is 90 degree. So 180 minus 90 is 90. So angle O will be equal to 90 minus 38. 90 minus 38, sorry, 52. 90 minus 38 will be your 52. I think the point is clear. Guys, go through the second question and try to solve by your own. Very simple question. Just have to do it in video. Right, 52 and second question, 52 question. Do by yourself. Thank you, guys. Thank you for your time. I think the point is clear to you how to find out. We have. Let me summarize. Like we have discussed about a circle, both circle, intersection of circles in multiple ways. We have already discussed about intersection of your point and a circle, the point of tangency, right? The question based on it, right? So try to do solve as many as question you can do. Try to solve your XRT, your reference group, right? Thank you guys. Thank you for the time. That's all about it. Thank you.